Hi everyone, welcome back to my channel. If you are working with machine learning models, like we already covered several machine learning like decision trees, to machine, XGBoost, AdaBoost, and etc. So you have probably reached a point where you ask yourself some questions, important questions, let's say. So how I know which model is really the best, and more importantly, can I trust the accuracy I'm getting from any model? So well, see, here's the truth indeed. Sorry. Uh, so just checking the accuracy on the training and test split dataset is a misleading, and I already explained also this when to use accuracy and when to use precision and recall. Please have a look in the previous videos. So in today's video, I will try to we are going to fix this. For instance, how to measure, let's see, your performance. So let me just introduce to you the cross validation. So what is the cross validation indeed? The cross validation, so instead of training and testing your algorithm on just random split of the data set, for instance, like this is the data set, split it into two parts, for instance, 70% and 20%. So instead of just split this into two parts, we have to do cross validation. So split data set into multiple times. So I will go through this step by steps. So this way, every data point gets in turns into the test and also in the training, and this will get, let's say, much more reliable performance. Yeah. So this the cross validation, it helps to detect overfitting, compare models fairly, let's say, in a fair way, and make better decision based on on the result. So whether you're choosing, for instance, decision tree, random forest, or XGBoost, so cross validation gives you a confidence that your result will hold in the real, let's see what. So I'm just let me just give you a real example. Assume that you are working with a real project and you have a data set. Now we are split the data set into two parts: training and validation, of course, and testing. And your performance, let's see, was working. Your model was working perfect, but in the running time, in the real time, in the real system, you will see the system is not working well because the data is different. Let's say the distribution of the data might be different, or maybe, of course, there's a drift in the data. But this cross validation is showing you or let you know that your data is, let's say, really right correctly distributed, okay, or come from the same distribution. So let me now there's three different ways for the validation. So either hold out, which is like we have done in many ways, let's say in many let's see project. We have, for instance, a data set which contains 100 record, so that we will split the data into 70 and 20%. This will get training for 70 records, and this will get 20 records. The advantage of this way is fast and simple, so it's not complicated, let's say. But here you will get high variance and less reliable. So high variance, it's like when you have a high variance, it means, for example, in the testing, in the testing example, you have high variance that your model is already overfitting, so it's not able to perform well on the testing data, let's say. And the second point, let's see, the second approach is key fold. So you will divide your data set into, let's see, a set of fold. For instance, say I have 100 data, 100 record, let's see, and I decided to split this into 20 folds, and each fold contains 20 record. So assume this, you have data set, let's see, you have data set with 100 record, just like for simplicity. Yeah, it's just I'm just assuming I'm just forgot to add this, but let's do this. And okay, it's just as example, and let's see you have uh, 100 records, for instance, 1 2 3 4 5, your data set, and you try use it from 1 to 20. This called fold 1. From 21 to 40, for instance, or 41, it will be fold 2, and etc. Now, how this will do in the training and testing? So we will assume that for the first fold will be as a testing, and the other, yeah, I have forgot to change this colors, sorry, my mistake. Will just easy to do it here. So this is the training, and this one here is the testing. So you will use all of these folds in the training, and this one will be in the test. So in this example, for instance, the training will be 80 records, and the fold one or testing will be 20 record. Yeah, why I have this here? It should be 30% indeed. I just remove 10%. Sorry. Yeah, and it is for the same fold. So you will divide your data set into fixed folds, and each run, let's see, each iteration, you will use one fold for the training, for the testing, and the others for the training. And the last one is leave one out cross validation. Assume that you have 100 data set, 100 record, and each time you will take one sample as a testing, and the other samples are the as the training. But this, you see, it's more reliable, less bias, but very slow. It's because you need to if you have a millions of records, you need to do it. You need to have a, let's see, a big PC. But normally we would use key folds to do the cross validation. So let me just show you this example here in the for the cross validation. You can just select it for, I mean, import it from the model selection, which is Skyline, and it's just super easy. Defined, because here I just show you the decision tree and support for machine. And here you can see this is a cross validation. I have the X, Y, and how many cross validations. For instance, I have defined 5. And after this, you will have the scores of each fold. And here you see we're just taking the mean of this and also the standard deviation. And if you see here, yes, for the decision tree, the accuracy is 96 plus minus 0.033. And in this one here, it's the support factor machine is 96. I mean, let's see, 97 plus minus 0.021. So this is how you from now you see my classifier decision tree or support factor machine is working perfectly. And because you see the standard deviation is very less. Let's see, neglectable. It's not that much. If it's much, it means one fold or maybe more than fold. It's far away from the mean. So you can see now which fold or which data it's different, and of course you can study your data why it's different. And I think that's it for today. If you like this video, please subscribe into my channel, like the video, and if you have, of course, any question, just drop it down in the comment below. I will answer. Thanks for watching, and see you next time.